In this experiment, we pushed an object across the surface and recorded its motion in Tracker. From the video, we extracted position versus time data in both the x and y directions. The goal of this lab was to construct a computational model using Newton's second law and compare the predictions to our observed data. The x position versus time graph is linear, which indicates that the object is moving with constant velocity. Because the slope of the graph is constant, the acceleration is approximately 0. To model this, I use the momentum principle, which states that the change in momentum equals the net force times the time interval. In the code, velocity is updated using Newton's second law, and position is updated using the new velocity since the observed motion shows 0 acceleration after the push. So I set the net force equal to 0 in the model, and when the net force is 0, velocity remains constant, so it should produce a linear position versus time graph. So here's the observed data plotted together with the computational model. The two lines very closely overlap, which indicates a strong agreement between the model and experimented data. Because the model assumes 0 net force and predicts constant velocity, and because this matches the first linear motion graph, this confirms Newton's first law, which is that an object in motion continues to stay in motion at a constant velocity when the net force is 0. So here are some questions. What if we flip the axes in Tracker? I chose the orientation of the coordinate axis. So if I flip the axes so that the positive x and negative x were interchanged, the numerical values would just change sign. So, for example, the slope would become positive instead of negative, but the physical motion would remain the same. Acceleration would still be 0, and the net force would also still be 0, so it only changes the signs, not the physics. And then what does that mean? When the net force is 0, it doesn't mean that no forces are acting on the object. It just means that the forces are balanced. That means that the forces cancel each other out, and the friction force is negligible enough to not count it. So there may be multiple forces acting on it, but they add together to give like a net force of 0. So that's the end of the presentation. Overall, the experiment demonstrates that when the net force of an object is 0, it moves with constant velocity, which is consistent with Newton's first law and the momentum principle. The computational model accurately predicts the observed motion under this assumption. Thank you.